Okay, today we're going to look at solving trigonometric equations. This particular equation is in the form 4 sine squared x minus 3 equals 0, and we're going to look to to find all the possible angles or values of x between 0 and 360 degrees. If you were working in radians, that would be between 0 and 2 pi radians. That satisfy this particular equation, that is 4 sine squared x minus 3 equals 0. So let's have a look at the solution. The first step involved here is to rearrange the equation so that it is in the form sine x equals something. That will enable us to inverse sine both sides to find out the possible angles. So we take our original equation, 4 sine squared x minus 3 equals 0, and rearrange it by adding 3 to both sides, then dividing both sides by 4, so that we have sine squared x equals 3/4. Now the next stage here involves square rooting both sides. However, you do have to be careful, since square rooting both sides allows for both a positive and negative solution. So when we do this, we have sine x equals either plus or minus the square root of 3/4, which could be expressed as plus or minus root 3 over 2, the square root of 4 being a whole number 2. Now you might recognise root 3 over 2 is an exact value for sine of 60 degrees. So what we'll do here is we'll consider this as two separate equations, sine x equals positive root 3 over 2, note the positive is not shown since that is default, and sine x equals negative root 3 over 2. That's the end of stage 1, or the part solution step 1, since we have now got the equation in the form sine x equals. This gives us, of course, two possible equations. Each of these can separately be solved. So, the second stage in this solution. Let's look at the first equation. Step 2, solve the first separate equation for x. That is the positive root 3 over 2. So we'll rewrite that down. And now we use our table of exact values to determine the first quadrant solution. That is the solution for the angle between 0 and 90 degrees. Now this can be done a number of ways. You can use triangles. Some of you may remember using triangles to work out these exact values with the Pythagoras theorem. However, I find it's easier simply to remember the values themselves. Root 3 over 2 has a sine of angle 60 degrees. So that comes straight out of a memorized table. Now, interestingly, this is only one of the possible solutions between 0 and 360 degrees. So now we use the unit circle to determine the next one. If we represent 60 degrees, remember, starting with 0 on the x-axis and moving anti-clockwise around to 60, 90 would be at the top, 180 on the left side, 270 at the bottom, and then back to 360 around one complete cycle or circle on the unit circle. So the 60-degree angle is actually in here, but I've represented it on the outside so it doesn't get too crowded. Now keep in mind, on the unit circle, sine is the y-coordinate or vertical height of this point here. Represented on the y-axis, we can see the root 3 over 2 that we require the sine value to be equal to, and we know from our table of exact values that this is 60 degrees. So the other possible solution to this would also have the same y-coordinate, which means the same vertical height. So we simply move horizontally across at the same height level until we intersect the circle at the same position. And when we do this, we see that it is by symmetry a 60-degree angle on both sides, and so therefore 60 degrees on the left and 60 degrees on the right from the x-axis. That makes that 180 minus 60, which is 120. So we say from symmetry, obviously the first solution was already there, 60 degrees, and the second one is 180 minus 60, which gives us 120. And together these two angles represent the two possible solutions between 0 and 360 for the first equation that we solved out of step 1. Now we do exactly the same thing for the second equation. However, we note that this is now negative root 3 over 2. So if we come up here, solve the second equation for x, sine x equals negative root 3 over 2. And before we actually do this, keep in mind that a negative sign value would be down on the lower section of the unit circle. So we would be looking for angles that would be in line with a horizontal value, horizontal line going through negative root 3 over 2. Being a unit circle, of course, the radius is 1, so that would be 1. Negative root 3 over 2 would be approximately negative 0.866. So we use exact values to determine the first quadrant solution between 0 and 90. That's exactly the same as before. No surprise, same answer. Now we use the unit circle to determine the possible solutions for the negative sine x value. Now notice over here I said other possible solutions since 60 was already a solution. Here 60 is not a solution, that is just a reference value. We're looking for angles that give us a negative sine value. So on the unit circle, now we have our 60, and as before the 120, but root 3 over 2 is a positive value. We want negative root 3 over 2. So as I mentioned, we're looking for 2 points on the unit circle which have a y coordinate of negative root 3 over 2. And we can see from symmetry these angles are all similar, and therefore we're looking for a value of minus 60 degrees from 360. That will give us 300, or another 60 degrees added on to 180 degrees, which of course gives us 240. So from symmetry we say x is equal to 180 plus 60 or 360 minus 60, which gives us 240 or 300 as mentioned. I'm not sure what happened here, just ignore that. Now that's not quite finished, since now we have two solutions for each of the two equations that we started with. We must list them all. So list all the possible solutions for x, combining the solutions for x from the previous two steps. We have 60, 120, 240 or 300 degrees. However, sometimes it's nice to express these as a set in set notation. So we say that x is an element of the set 60, 120, 240 or 360 degrees. These curly parentheses represent set notation. I like to highlight the solution so that it's easy for anyone looking to find out the final answer. Comparing our solution to the original question, we see that in fact we have answered everything. I hope this has been useful to you. Please subscribe, and I will put up solutions to any question that you request. That's all for now.